All right, so the first thing we need to do is determine when the counter is exhausted, when that was not in our original XCP result. So let's go ahead and do that now. So and that's going to be in our header, so we're going to just go into the include folder. So here we have everything was okay. There was a parameter error. Authentication failed, but that's for later. The buffer was too small. And we also need the XCP counter was exhausted. Okay. Now we're going to need some way to determine when the range has been exhausted. So let's go into our source file. And if we go to we're going to want to call it probably before the XOR. So we're just going to want this to be called to determine if we've exhausted the counter or not. So CP counter. The counter is a 32-bit word, so uint32 counter, and then the length. So a whole block, so this will be a constant, a whole block of size t is going to be the length divided by the XCP cha-cha 20 block size. The remainder of that is going to be constant. The length mod XCP cha-cha 20 block size. And then we're going to need to know how many blocks are needed. So blocks needed. And then also blocks available. So if the value of, I'll make that a plural, blocks. If the value of whole blocks is greater than the maximum value of a uint32, we will return 0. So we're going to need to do some safe division because we want to avoid doing something like the length plus 63 divided by 64, because when length is very large, this can overflow. So we're going to do a safer form of this type of division. So the blocks needed is going to be a cast uint64 of whole blocks plus, we can do same line. I don't know if this makes it harder to read. Less than or equal to blocks available. All right. So we don't add 63 to the length and divide because the expression can overflow before the division happens. So what we want to do, or what we're doing here, is we're dividing first, and then we're taking a look at our remainder, and then we're doing this security calculation in 64 bits. All right, now if we look at our XCP Cha-Cha 20 XOR, we have this null check here. We can get a little bit more detailed or better about this, so we'll space this out a little better too. So if the key is equal to null, or the nonce is equal to null, or let's say the input is equal to null, or the output is equal to null, and the length does not equal 0. Because the length is 0, it's okay if those are null. Right? Yes. Yeah. Okay. So if the output is null and length is not equal to 0, open, open, close, then we'll return the parameter error, and then we want to apply our range counter. I think that's what it was. XCP counter range available, XCP counter range available, counter and length. XCP counter range available, pass in the, what do we call it here, counter and length. Perfect. Then return XCP's counter was exhausted. Exhausted. I'm going to tentatively say I spelled that correctly. And since we're touching the processing loop, let's take a look at this counter plus plus. So we can actually refactor this a little bit. And we can increment after we examine the take, because we don't use the counter in here at all. So we have our offset is increased by the take. And if the offset is less than the length, then we will increment the counter. All right, so we'll save this. So we'll want to do two things here. Let's say theoretically that we were encrypting a really long series of things, and all right, so say this is the last legal block, and then this is the first block of reuse. So here, this would be uint32 max. There's exactly one legal counter value left. So we will do this by calling, or we'll test this by calling the cha 20. I'm sorry, I'm a horrible typer. Block. I think it was key. We'll need to use uint32 max here because we want to call at the very far reaches of what it can support. Pass in the nonce, and then I think we can name that whatever we want in the test. And then we're going to call the Zor API with an all zero input. That'll be the key. uint32 max, the nonce, the input, actual and length. And that's because Zoring has this property, right? So 0 Zor, the key stream, is going to equal the key stream. So encrypting 64 0 bytes should produce exactly the same bytes as the raw cha-cha-20 block. So we need a test to make sure that works. Then, once we're on this reuse side, we want to make sure that we return that the counter has been exhausted. So we're going to want to have our output. We want to know, because in the code, we want to make sure that we are not changing anything unless it's valid, unless the entire operation is going to be valid. So we're going to want to fill output with a sentinel value. So it's going to look something like, we're going to memset the output. So what is that? Destination, output, some obvious value that we will notice, like, I don't know, 0A5. That doesn't really matter. We just want a value that we will absolutely recognize. And then size of output, we want to fill that up. And then we're going to call this at the length of 65. This same stuff we were doing over here, we want it with a length of 65. So what's going to happen is it's going to go through the division. Where is that function? It's going to go through this division and determine, hey, we can use the first 64 for a valid block, but then we're going to spill over into a counter wrap, and that's not valid. So we're just going to return our XCP counter has been exhausted, our XCP counter exhausted. That's what we're looking for. We want that failure value back. So let's go ahead and write those tests. All right, so let's start the implementation. So we're going to go into the tests folder. We're going to add a new test. So we're going to call this the cha-cha 20 XOR limit test. We will need our XCP header. We will need our test header. But we will also probably need a string because we're doing memset. So our first test will be, so the final block will be this stuff. So the final block is working and is allowed. Test final block is allowed. We're going to need our key. If you're following along and typing, I would copy this value because we're going to set our key, our nonce, our input, the expected output, and the actual output. All are going to be UN8s. So we'll have our key, and that is going to be of size XCP cha-cha 20 key size. And we're going to initialize that to 0. Then we're going to have our uncapitalized nonce. And that is going to be our XCP cha-cha 20 nonce size. All of these are going to be initialized. We want all the buffers to be completely full of zeros. Then we're going to have our input. All right. So we are just going to call, so we're using failures as our return. So failures. We want to call our XCP cha-cha 20 block. Oh, I think it's just block. With the key at uint32's max. We'll pass in the nonce and our expected. Then we will need to do our XOR so that we can compare them. We just do size of actual so that we don't have to predetermine that, or determine that here as well. And then we're using that test function that we defined in our header. Okay, so that is this test. So we are doing the block at uint32 max and the XOR at uint32 max, and then we are comparing the actual and the expected. Next, we want to make sure that the first time it has to wrap, it's rejected. So we'll mostly need these same ones again. So save ourselves some typing time. Static int test. We'll call it just first wrapping request is rejected. That'll be a void. Okay, so we're gonna need the key, the nonce, the input, the output, and we'll need a place to store the values that should be unchanged. So the key, the nonce, the input, key, nonce, input, we are going to need it to be one bigger because it will be one past the 64. The blocks, all the block sizes are going to be one larger. And then, so we need the key, nonce, the input. We will call this, let's say, output, input, output, and then the unchanged values that we should be touching. And those do not need to be initialized to 0. Right? Keys are all 0, nonces are all 0, input is all 0. Our output and our unchanged bytes should not be touched. So then we are going to set our output to a canary value. Oh, I already picked, what was it, 0A5? Okay. So x85, size of output, and we want to set the unchanged buffer to the same thing so that we can ensure that they are equivalent. And the size of changed. So these are going to be, because these are 64, output is actually going to be 65 because it is one more, and unchanged is going to be 65 because it is one more. And then we are going to do the same thing with the failures variable. URES, right? XCP cha-cha 20 Zor key UN 32 max not input output size of output is not equal to XCP counter hosted. And then counter x house case preserves input, preserves the output. Output and then we're just going to return failures. All right, now we're going to want our main function. So wait. And we are just going to return the two tests. Return this. This plus all right, now we just need to add this to our CMake and build and test. So we'll need to add an executable. We can just call it the XCP cha-cha 20 Zor limit test. And that file is going to be under tests, cha-cha 20 Zor limit test.c. We will need to link library so it knows where to find the function. We'll link it privately with XCP. And then we will add another test. Well, we're adding this test to the existing, we already have a block test. So we are adding the Zor limit test. So name is the XCP chop 20 XOR limit test and command XCP chop 20 XOR limit text. All right, so let's go. Okay, perfect. That built and ran. So now we can just ctest. All right, so all of our tests are passing. So we are having the expected behavior with the counter wrap prevention. And then of course our block test also passed.